is paper 1, November 2014. Question 1. Circle the multiple of 9 from this list of numbers. So your multiples of 9 are just your 9 times tables. So 9, 18, 27, 36, 45 and so on. So the one there that's in your 9 times tables is 27 because it's the answer to 9 times 3. So remember, multiples times tables. Part B, circle the factor of 40. The factors are what you can divide the number by, so you're looking for something that you can divide 40 by, or something that divides into 40. So 6 doesn't go into it, 12 doesn't go into it, neither does that, 20 goes into it twice. So it's a factor of 40, or I've just written down there 40 divided by 20 gets you 2. So factors are what you can divide it by. Then part C, circle the square number. Square numbers are the answer you get whenever you times a number by itself. So the answer to 1 times 1, 2 times 2, 3 3s, 4 4s, 5 5s, 6 6s and so on. So the one there that's a square number is 16 because it's the answer to 4 4s. Then D, circle the prime number. The prime numbers are the numbers that they're a bit awkward and they don't really divide by anything. There's a wee rhyme for the first few, the 2, 3, 5, 7, 11. And then after that it goes 13, 17, 19. So the one there that's a prime number in that list would be 13. So they're the awkward ones, and try to learn the first wee bit of the rhyme because they're the ones that come up the most. The 2, 3, 5, 7, 11. But it went a wee bit beyond that for that question. They were looking for 13. Question 2. So 30 people gave their favourite flavour of ice cream. Complete the tally chart and pictogram, and remember to complete the key for the pictogram. So here you are just completing the frequency table or the tally table. So this box here was empty, so you just count over here. There's the 5 there, then 6 and 7, and write a 7 in there. And for here it was the tally that was left out, so the number here was 5, so you just do 1, 2, 3, 4 and then the wee 5 going across it. Then down at the bottom, where they are wanting you to complete the key and fill in the pictogram, you would need to get the key first of all by looking at either the picture for chocolate or the picture for strawberry and looking back up to see what numbers they actually represent. So the chocolate one would probably be the easiest one because the pictures are whole, there's no wee half ice creams like there is in the strawberry one. So chocolate, there's 4 pictures, and up in the frequency table it tells you that chocolate, that there were 8 people who picked that. So if the 4 wee pictures mean 8 people, that means each wee picture must be 2. So you're going 2, 4, 6, 8. 2, 4, 6, 8. Then that means that you're able to go and fill in the rest of the picture then. So put a wee 2 in there for the key. And then up here, vanilla, there were 10 people who chose that. So 10 people divided by 2 means that you would have 5 pictures, so 5 wee pictures of ice creams down here. And then the other one that was left out was the mint choc chip, and there were 5 people who chose that. So 5 divided by 2, there should be 2.5 wee pictures in there. So that would be 2 people, that would bring you up to 4 people, and that one would bring you up to 5 people. Then number 3 gives you a recipe for plum jam, and this is for 8 jars, and the rest of the question is all about 4 jars. So for you to get from 8 jars down to 4 jars, you're just halving everything, so half of all of these numbers would get you the ingredients for 4 jars. They've even given you a wee picture there, so there's a picture of 8 of them. For you to get it down to 4, you're just getting rid of 4 of them, you're cutting it in half. The main problem with the question is that these ingredients are all in measurements like kilograms, and down here they're looking for the answer in grams. So Jane wants to make 4 jars of jam rather than 8. How many grams of plums does she need? So if you go here, the plums, it's 1.2 kilograms. So first of all you need to know that there's 1,000 grams in a kilogram. So 1.2 kilograms would be 1,200 grams, and that's for 8 jars. So divided by 2 would get you 600 grams for 4 jars. So 600 grams would be your answer in there. Then part B says that Jane already has 860 grams of caster sugar. How much more caster sugar will she need to make 4 jars of jam, and state the units of your answer. So I just kept everything in grams the way the last one was. So caster sugar, first of all, up here it says that there's 1.8 kilograms needed. That's what she needs. So I changed the 1.8 kilograms, timesing it by 1,000 would be 1,800 grams, and that's for 8 jars. So divided by 2 would be 900 grams for 4 jars, and she's already got 860. So take off the 860 that she's already got means that she would need another 40 grams. And remember, it does say state the units of your answer, so you would need either the word grams or just G for grams in there. So 2 marks for that, 1 for your method and 1 for your working out. Question 4. There are 2 boxes, box A and box B. Altogether there are 30 oranges in the boxes. 7 oranges are moved from box A into box B, and the number of oranges in each box now is the same. So how many oranges were in box A at the start? So if there were 30 oranges altogether in the boxes, split that up into 2 would be 15 each. If they were even, if there was the same amount in each one, it would be 15 in box A and 15 in box B. But they said that 7 had to be taken out of A and put into B for them to be even. So that means that box A must have been 7 up from that. So 15 plus 7 would bring you up to 22. And box B would be 15 down 7, so there would be 8 in box B. And they were looking to know just how many there were in box A at the start, so there were 22 at the start. So if you were to take 7 oranges out of box A, so 7 oranges off the 22, and put them into box B, that means that there would be 15 in each. So there were 22 to start off with in box A. Question 5. Put numbers in the boxes to make the calculations correct. So 27 plus what would get you up to 60? You could just do that one in your head. The 27 plus 33 would get you up to 60. Or if you wanted, you could do taking away some and do 60, take away 27, and then it just depends whatever way you would take away. Not take away 7 you can't do, stroke that out, make it a 5, carry the 1 to there. 10 take away 7 gets you 3, 5 take away 2 would get you 3. Probably easier just for you to do that one in your head, it is only worth 1 mark. 5b, 6 times what would get you 96? Again, it's only worth 1 mark. If you can do it in your head, fine. I did a dividing sum here. So 96 divided by 6, 6 into 9 goes once, remainder 3, 6 into 36 would go 6 times. So 16 in there in that box. And the last one, what divided by 9 gets you 15? You would just be going in reverse there and do 15 times 9. If you can get 135 in your head, that's fine. I did a multiplying sum. So 9 5s are 45, 9 1s are 9, plus the 4 would get me 13, so 135 for that one. So just 3 calculations without a calculator there. Number 6 says shade 3 squares so this pattern has exactly 1 line of symmetry. So they've said exactly 1 there because they don't want it to have 2 or 4 lines of symmetry, they want it just to have 1, and they give you a practice grid as well, and then you have to have your final answer down here. So I've already drawn in the line of symmetry that I'm wanting this to have, and I have used a bit of tracing paper and traced out the wee squares that were already shaded in underneath, and I've traced out the line of symmetry as well. So for me to make this symmetrical, if you can do it without tracing paper, that's fine, but you're allowed tracing paper in the exam, you just need to ask for it. So to make it symmetrical, I'm just going to turn the bit of tracing paper over so that it's back to front, and put the line of symmetry back on top of it again. So go like that. So the line is going back on top of the line, and then you can see the squares that I would need to shade in then. So I would need to be that one up there, and then these 2 down here in the corner. And then just move the tracing paper away and shade in those 3 wee squares then. So shade in 1 there, 1 there, and 1 there. Number 7. Nick plays 8 games of chess and he wins 6 games. What fraction of the games did he win? Give your answer in its simplest form. So he won 6 out of 8. So writing that as a fraction would just be 6 on the top, and then out of 8 would go on the bottom. and they wanted you to simplify it, so just divide the top and bottom by whatever you can. In this case it would be 2, which would bring it down to 3 out of 4 or 3/4. Part B says that Nick loses the 9th game and he wins the 10th game. Then he says, I've won more than 75% of the games that I've played, is this correct? So if it was 6 out of 8 up here and he loses the 9th game, that means that the 8 would go up to 9, but the 6 would stay as it is because he didn't win that game. But then he wins the 10th game, so the number of games on the bottom would go up to 10, and the 6 would go up to 7 because he won that one. So as a fraction now, he's won 7 out of 10. So down here in the answer space then, I've changed 7 out of 10 into a percentage, which is 70%. So no, he hasn't won more than 75%, he's only won 70% because he's won 7 out of 10 matches. So it would be 1 mark for having that ticked and then 1 mark for your answer. Question 8. 278 students are going on a trip, and at least 1 teacher must go with every 15 students. Work out the smallest number of teachers who must go. So if 10 teachers were to go, that would be enough for 150 students. And the 278 students that you've got, that's near enough, double the 150. So 150 doubled would be 300. So it'll nearly be 20 teachers that you'd need, but not quite as many as that. So once I knew what it would be if 10 teachers went, so 10 teachers going would be enough for 150 students to go as well. I then did a wee sum to work out what it would be for 9 teachers going and 8 teachers going. So if 8 teachers went, that would be enough for another 120 students to be helped out and covered. So the 10 teachers plus the 8 teachers would be 150 plus 120. That would be enough for 270 students to be allowed to go, which isn't enough because there's 278. So they would need 19 teachers to go. So yes, the 19 teachers would put them slightly over because it would be 150 plus 135, which would put you up to 285, but you're better having too many teachers because it said at least 1 teacher has to go to be there for every 15 students. So you would need 19 teachers there. That mightn't have been the way that you worked it out, but 3 marks, just 1 for getting the 19 teachers, and then 2 marks is for any other way that you worked it out. Number 9 then. Mary buys 4 pencils and each pencil costs 45p. She pays with a £2 coin. She gets exactly 5 coins in her change. What are the 5 coins? So 4 pencils costing 45p. There's a calculation there doing the 45p multiplied by 4 pencils. So 180 pence, which would be £1.80. Or you could just add up 45, 45, 45 and 45 to get the £1.80. So she paid with a £2 coin, which means that she got 20p change, but they didn't just give her back a single 20p coin. It said that there were 5 coins given back, and what were the 5 coins? So I just went on then to split the 20p up into 5 coins. So I went with a 10, a 5, a 2, a 2 and a 1. Question 10. There are 10 balls in a bag and they're either red, blue or yellow. There's twice as many blue balls as red balls, and there's more red than yellow. A ball is taken at random from the bag. Fill in the table to show the probability of taking each colour. So I wrote down first of all blue, red, yellow, and then I just tried different combinations. So I tried first of all if there was just 1 yellow, and it said that there had to be more red, so maybe just 2 red, and there has to be twice as many blues, so there would have to be 4 blues, but then 4, 5, 6, 7 that would total up to, not the 10. So I went and put the yellow up to 2 then, and there has to be more red, so I tried 3 red, and the blue would have to be double that, so I tried 6 blue, but then that adds up to 6, 7, 8, 9, 10, 11, so that goes over the 10. So I went back down to having just 1 yellow again, and then instead of having 2 reds, I put the reds up to 3, and then the blue has to be twice that, so blue would be 6, and then 6, 7, 8, 9, 10, that combination totals up to 10, so there must be 6 blues, 3 reds and 1 yellow, and then just write the probabilities as fractions down here. So the red would be 3 out of 10, blue would be 6 out of 10, and yellow would be 1 out of 10. You didn't need to show as much working out for that. The 3 marks are just for those 3 numbers in the table. Number 11, write 2 5/7 as an improper fraction. Improper means top heavy. So you take the 2 at the front and multiply it by the 7 at the bottom to get 14, and then add on the 5 at the top to get it up to 19. So your answer is 19/7. This 2 at the start, the two whole numbers, would be a 7 out of 7 and a 7 out of 7. So you could do it that way if you find that easier. So 7 out of 7 is one whole, then another 7 out of 7 would be two wholes, and then another 5 out of 7 at the end would put it up to 7, 7 and 5 is 19 out of 7 then. 11b, circle the fraction that is equivalent to 2/3. That means you simplify it down and you would get 2/3. So 4 out of 9 doesn't simplify because there's nothing you can divide both of those by, and the same with 7 out of 8. 15 out of 20, both of those numbers divide by 5. So if you divide the top by 5 you get 3 and the bottom by 5 you get 4, so that simplifies down to 3/4. Then so that one won't work. The 16 out of 24, both of those numbers are in your 8 times tables, and divide them both by 8 and you would get 2 out of 3 or 2/3. So it's the last one there, the 16 out of 24 is equivalent to or the same as 2/3 because that's what it simplifies down to. 11c, so put these numbers in the boxes to make the fraction equal to the decimal. So you want the fraction equal to the decimal. So I chose the 9 put over the 2 because 9 over 2 means 9 divided by 2. And 9, if you think about money, £9 split in half would get you 4.50 or 4.5. Number 12, solve 6x equals 54. That just means 6 times what gets you 54, or do 54 and bring that times by 6 over and divide by 6 to get you 9. Just one mark for that, so you don't necessarily need any working out. Part B, solve 3y plus 15 equals 9. You could sit and try to work out 3 times what plus 15 equals 9, and sometimes that works out nicely and you can do it like that, but sometimes it's a negative number or decimal number that's more awkward. So I would do it by trying to solve it and get y on its own. So leave the 3y for a wee minute and bring the plus 15 over and take it off the 9. So remember, whenever you change sides, you change signs. So the plus 15 would come over here and turn into a take 15. So 9 take away 15 would get you minus 6. So 3y equals minus 6. And then at this stage you can go 3 negative 2's would get you negative 6 and go straight to your answer. Or if you don't see that, you can bring that times by 3 over and divide by 3. So negative 6 divided by 3 would get you the negative 2. So 2 marks for that. You need some sort of working out. It mightn't look exactly the same as mine, but you need some working out. 12c, solve again, and this time you have got letters on both sides. So I do these questions by trying to get all of the letters together on the first side and all of the numbers together on the other side. So I would be bringing that 2w over here and doing 4w take away 2w gets you 2w. And then get all the individual numbers over here on the second side. So bring the plus 2 over, and whenever you bring it over it turns into a take away 2. So 7 take away 2 would get you the 5. So this looks a lot better now. At least you've got all the w's together and all the numbers just on the far side. So 2w equals 5 means w must equal 2.5, or bring that 2 over and do 5 divided by 2 is 2.5 or 2.5. Number 13, you've got a conversion graph changing measurements from inches into centimetres, and they've drawn this line here for you. Shaz has 150 centimetres of material and she needs 75 inches of material to make a skirt. Does she have enough material? And it says you must show your working out, so you need to show anything that you've used up on the graph. So 150 centimetres, if you look up here, it doesn't go up anywhere near 150, it stops at 30. So you need to use some number here and multiply it to make it into 150. I chose 15. So I went up the side here, halfway between the 10 and the 20, up to 15. across to the conversion line and down to see what it turned into in inches. So 15 centimetres is the same as 6 inches. So I've got that written down in my working out space. So 15 centimetres equals 6 inches on the graph. And then it's very easy for you to get from the 15 centimetres then to the 150 that they're wanting to work out. Just times it by 10. So take the 6 inches from the graph and times it by 10 as well to get 60 inches. She needs 75 inches of material and she's only got 60. So you need to actually answer the question then by saying no, she doesn't have enough material. She's 12 inches short of what she needs. Actually more than that, she's 15 inches short than what she needs, because she's only got 60 and she needs 75. Question 14, part A. So measure and write down the 3-figure bearing of B from A. 3-figure bearings are just angles measured from north, going clockwise, and the 3-figure thing just means that if you get a small answer that's only like 42, you have to put a 0 in front of it. And it's the bearing of B from A means that you put your protractor at A because that's where you're going from. So you would set your protractor like that at A, and you set it so that it's sitting like a capital D shape, and make sure that you've got that baseline sitting right on top of the north line like that. And this wee middle bit here has to be down at the corner. And you read your outside numbers round because that's where naught is on the outside. And it's exactly 70 for this one, but it said that it had to be 3 figures, so make sure you put the naught in front of that. So 070 would be your answer. If those 2 letters there were the other way around, if it had said A from B, you would have been looking at that angle over there, and you would have had to do a 180 plus that extra bit. So make sure that you put the protractor at the right letter, whatever one it says it's going from. So from A means you put it at A. Part B then. Work out the 3-figure bearing of D from C. So from C means that you would be setting your protractor up here at C and working out where D is. So same as the last one really, make sure that you've set it in the right place and that everything up here, all these lines are sitting on top of each other. Read the outside numbers round, and it's 95. And again, 3 figures means it would have to be 0.95. It's only worth 1 mark, so if you don't put the 0 in there, you lose your mark. Also for this one, it had said work out rather than measure, because they had given you that 85 there. So you could have just extended that line on out and used that this has to total up to 180. And if that's 95, that would have to be 95 because of that F shape there. So you could have worked it out rather than you actually having to measure it for 1 mark. 15a, just draw the line x equals 2 on the grid. So you go to x, you go to 2, and you go a line going, or draw a line going up through that. Most people think that that line is called y equals 2 because it's sitting up the same way as your y-axis. But it's not actually going anywhere near your y-axis, it's not even touching it. The one that it's touching is the x-axis, and it's called x equals 2 because all of the points on the line have an x coordinate of 2. So that point there is the point 2, 1. This one is 2, 2. This one is 2, 3. That one is 2, 4. And that one is 2, 5. The first number there every time is 2. And that's your x coordinate. The x comes first. You read off the x and then the y. So because the x number is always 2, that is called x equals 2, that line. But I would just do it by remembering whatever axis it cuts through. So if it cuts through, if it touches the x-axis, it's called x equals something. So in this case, that's x equals 2. Part B then, just draw another line. This time it's the line y equals x on the grid. So y equals x is the slanty line because the y coordinate is always equal to the x coordinate. So that is the point 1, 1. That's 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And that'll get you the line y equals x. Just the slanty one going from corner to corner through all the squares is y equals x. Number 16. Here are 6 quadrilaterals. They didn't have these lines drawn on, I've drawn them on. So they gave you 6 quadrilaterals, nice pictures to look at, all labelled and everything. You don't need to worry about what each of them are called or anything like that. And the question they ask you then is just write down the names of the 3 quadrilaterals that have diagonals crossing at right angles. So diagonals are those lines that I've drawn on, going diagonally from one corner to the other. So crossing at right angles would be the square, the kite and the rhombus. These other ones here, they don't have right angles here where the diagonals meet. So square, kite, rhombus are your 3 answers. So 2 marks there. You just lose a mark anytime you get one wrong. On the next page then, it says 3 quadrilaterals are square, rectangle, parallelogram. The parallelogram could be the odd one out. Give a reason why. So the square has 4 sides the same and 4 right angles. A rectangle has opposite sides the same and 4 right angles. A parallelogram has opposite sides the same but doesn't have 4 right angles, so that's what makes it different. It doesn't have 4 right angles. So I've just written there, the 4 angles in a square and rectangle are 90 degrees, parallelograms have no right angles. So that would be why it would be the odd one out. Part C. 3 quadrilaterals are rectangle, parallelogram, rhombus. Tick the one property that these 3 quadrilaterals have in common. So a rectangle, just going to draw out some smaller pictures of them here instead of having to flick back to the last page. So all 4 sides are the same length. That's only true in a rhombus. So a rhombus is like a slanty square, so those 4 sides there are all the same length. A parallelogram is a slanty rectangle, so it has 2 long ones and 2 short ones, the same as the rectangle. All 4 angles are equal. That is true for all 4 angles are equal. That's only true for the rectangle. That has 4 right angles in there. That doesn't work for either of these other 2. It has 2 big angles and 2 wee angles. Diagonals bisect each other. So it had the diagonals on the last page. That's going from one corner to the other. So the diagonals in the rectangle would be there and there. They do bisect each other because that bit's the same length as that and that's the same as that. The same for the parallelogram. The diagonals aren't the same length. You've got one long diagonal and one short diagonal, but they do bisect each other. They do cut each other in half because that bit's the same as that and that length's the same as that. And then the same for the rhombus. It would bisect each other as well, the diagonals, because those 2 wee bits are the same length and those 2 are the same length. So that's the one there that should be ticked. The last one then, just to rule it out, 2 lines of symmetry. A rectangle and a rhombus have 2 lines of symmetry, but a parallelogram doesn't have any. Most people think that parallelograms have 2 lines of symmetry. They don't. It has order 2 for rotational symmetry, but doesn't have any lines of symmetry. A rhombus has lines of symmetry where the diagonals are. A rectangle, those diagonals aren't lines of symmetry. The lines of symmetry are going down and across like that. So that one's definitely not true. Parallelogram doesn't have any lines of symmetry, never mind 2. Number 17. Anna wants to know the colours of cars in the school car park. Brian wants to find out what students think about school dinners, and Carl wants to test people's reaction time. And they're just asking you to pick which one of these they should be doing, which one of these they should be carrying out. So choose the method each person should use. If you want to know the colours of cars in the school car park, you'd go out to the car park and record the colours that the cars actually are. So that would just be an observation then for the first one. Then what students think about school dinners, you'd need to hand some of the students out a questionnaire and ask them some questions about what they think about the school dinners. And the last one, the people's reactions times. For that you would need to carry out some sort of an experiment to see how quickly they react to things. So 2 marks there. Just if you get one wrong you lose a mark, another one wrong you lose another mark. So lose a mark for every one you get wrong pretty much. Number 18. Here's the net of a cuboid and the net shows the area of each face. So the net is just the opened out flattened version of this 3D cuboid. So this would be what you would fold up to make into the cuboid, and they've given you the area of all of the faces, which you get because they're rectangles by multiplying the length by the width. So I just took this first face here, which had an area of 15, and thought which two numbers multiply to get me 15. So 5 and 3. And then if this is 3, this one here would need to be 3 as well, because when they're folded up, those two edges would be touching. And then the 12 would come from 3 times 4. The 12 could also come from something like 2 times 6, but the 2 and the 6, it wouldn't fit in there to be the same as the 3, and 2 and 6 don't go into 15. So the 12 comes from 3 times the 4, and then it works for the 20, because it would be 5 down there multiplied by 4 to get the 20. So in the working out space, all I did was write out where I got where the 15 out the length and the breadth and the height. All you do to get your volume is multiply those three together. So you would be multiplying 3 by 4 by 5 or 4 by 5 by 3. It doesn't matter which order you do it in. So the sides are 3, 4 and 5, so the volume would be length times breadth times height, 3 times 4 times 5. 3 4s are 12, and then times by the 5 will get you 60. Number 19. The manager of a leisure centre uses this question in a survey. How much time do you spend taking exercise? And then those are the different boxes that they've got to tick from. Write down 2 things that are wrong with this question. Well, first of all, they just say, how much time do you spend taking exercise? They don't say each day or each week or each month. So there's no time frame given there. It should be, how much time do you spend taking exercise each day or each week or something like that. Then another thing that's wrong with it is whenever you look at the answer box, there's an overlap at 1 hour. So if somebody, for example, did exactly 1 hour's exercise each day or something, they would be able to tick either this box or this box, and you wouldn't want that. You would want it that they would only be ticking one box there, so they shouldn't have that overlap. Then another thing that's wrong with it as well, if you wanted to put that, is that there's no box for anybody who exercises for over 4 hours. So if they were maybe thinking of it as being how much do you exercise each week, they might be thinking, yeah, over 4 hours. So there's 3 things wrong with there, you just need to pick out 2 of them. Part B, complete the response section for this question. How many days in a week would you use the leisure centre? So days in a week, there's obviously 7 different options there, so I grouped mine together, 0 to 1, 2 to 3, 4 to 5, 6 to 7. If you didn't do that, just make sure that you haven't overlapped, that you haven't ended with 1 here and started with 1 here. You could have done them completely separately and just had 0, 1, 2, 3, 4, 5, 6, 7. That's fine as well. So only worth 1 mark, you didn't have to group them together like that. Number 20. It says you will need a ruler and compasses to answer this question. Construct the angle bisector of angle A. So bisector means cut in half. So for this question, it said that you need your compass. So this is how you would do it then, to cut the angle in half. You would get your compass, open it out to whatever distance you want, a decent enough distance though, because if you put them too close together, the compass is really hard to use. So open them out a decent amount, put the pointy bit down here at the corner, down at A, and do an arc over that line. And then just keep the compass the same and do an arc over the other line down there at the bottom. So you've got this point and this point where your arcs have crossed over the original angle. So you use those 2 points then and put the pointy bit of your compass at each one. So put the pointy bit there and do a bit of an arc out here in the middle. And then go and put the pointy bit at the other one up at the top and do another arc out in the middle. And then after that, where your 2 arcs cross over, if you get your ruler and join that cross back up to the corner of the angle here, and that will have actually split that angle in half. And if you want, you could get your protractor and check it. It says that you're not allowed to use your protractor, so you can't just use your protractor for this, measure it and cut it in half. You have to use your compass. So I'm just checking here. If I measure that angle, it's nearly 70, so halfway would be about 35, and it is near enough that. So it has been cut in half, it has been bisected. Right, number 21. The table shows the length of the forearm and the height for 10 people. So comparing the length of their arm with their height. And the scatter diagram of the data is shown opposite on the other page. It says another person has a height of 145 centimetres, so there's nobody in the table there with a height of 45. So they're talking about somebody else with a height of 145. Use the scatter diagram to estimate the length of their forearm and show clearly how you found your estimate. So if you go to the scatter diagram, the points are all scattered all over the place. The first thing that you need to do is draw in your best fit line. I would always do that by drawing the sausage shape just around the outside of all the crosses, just because I think it's easier to see how slanty your best fit line should be going. So you cut the sausage in half long ways then. And the person's height was 145. So if you go to height up the side and look to see where 145 is, so there's 140 and 160, so 150 would be halfway at that point. So 145 you'd have to go across in the middle of the square, and you would need to have this line drawn in because it said for you to show you're working out. So make sure that you don't just stop at the sausage, that you go straight over to the best fit line and then down to read off the length of the forearm. For me, I got it to be, there would be 20, 21, 22, 23, 24, 25. So I got it to be between 21 and 22. So for my answer, I put 21.5. You mightn't have got that. It depends on the best fit line. But what they're really looking to see there is that you have your best fit line drawn well enough and where you've actually gone across. You need to have those lines in there. Then 21b says an approximate formula connecting H and F is this. Choose a person from the table and test the formula. So you could choose anybody, there were loads of people there. So I just chose person A. So if I go back to person A, their forearm had a length of 11 and their height was 108. So put F equal to 11 and H equal to 108. So F equal to 11 and H equal to 108. And substitute in 11 instead of the F. So do 4 times 11 plus 60 and see if you get 108. So my working out down here. So 4 times 11 would be 44 plus the 60 would get you 104, not 108. For the person that I chose then, it didn't work for me. It does work for some of them. So you could have chosen any of those other people there in the table and it does work for some of them. It just didn't work for the one that I picked. All they were really wanting to see there is, do you know how to substitute into the formula? You can tick either box here depending on whether your person worked or not. The last one then, number 22. 3 electric cars are tested by driving them around a track until the battery runs out. The table shows some information about their performance. So it tells you the total time that they travelled, the average speed that they were travelling at, and then the total distance that they got before the battery ran out. So complete the table. So they'd given you 4 hours and 35 kilometres per hour. So for you to work out the distance that they travelled, this just means they go 35 kilometres every hour, so times it by the 4 hours to get the 140. Or you could use there your speed, distance, time triangle. Speed, distance, time. And for you to get the distance, you do the speed multiplied by the time. For car B then, they travelled 40 kilometres per hour and they got 180 kilometres away. So if you're working backwards then in the table, you'd be doing what times 40 would get you 180. So do 180 divided by 40. Do the distance divided by the speed to get the time. So without your calculator then, 180 divided by 40, I divided it by 4 and got 45. And then you're wanting to divide it by 40, not just 4, so divided by another 10 would take it from 45 down to 4.5. The last one in the table then, you're wanting to know 3 times what would get you 150. So do 150 divided by 3 to get the 50. So do the distance divided by the time to get the speed. Distance divided by the time to get the speed. So I've done some working out down there. You mightn't have that. The 3 marks are just for the 3 numbers in the table. 22b. 2 cars are driven around a 10 kilometre track. Both cars leave from the start line at the same time. car X travels at exactly 40 kilometers per hour and car Y travels at exactly 30 kilometers an hour round this 10 kilometer track. How many minutes will it take before they pass the start line together again? So you need to work out first of all how long it's going to take each car to get around the track to know when they'll be back to the start together again if they're both travelling at different speeds. So 40 kilometers per hour for car X means that it'll go 40 kilometers in 1 hour, so it'll take an hour to go 40 kilometers, but the track is only 10 kilometers, so it won't take as long. It would take a quarter of the time because it's a quarter of the distance, so a quarter of an hour would be 15 minutes. So car X takes 15 minutes to get around the track. Car Y then is going a wee bit slower. It's going to take an hour to only go 30 kilometers, but the track isn't even as much as that. It's only 10 kilometers, so it's a third of that. So 30 divided by 3 to get the 10 kilometers, and an hour divided by 3 is 20 minutes. So the second car is going to take 20 minutes to get around the track. So if this one takes 15 minutes and this one takes 20 minutes, you can go up in 15s and up in 20 until you see which number is the same, and that will tell you when they'll meet again. So 15, 30, 45, 60, 20, 40, 60. The two numbers that are the same there are the 60, so it will take 60 minutes or 1 hour before they are sitting together again at the starting line for that one. So only 2 marks for that one, quite a bit of working out. So you would get a mark for looking at this bit, looking to see how long it would take them to actually get round the track, and then a mark for seeing when the times are going to meet up again. And that's the end of that paper.